Alright, time for another draftphysics.com, debatephysics.com also. A video presentation. So I made a video and then I had, oh gee, the asshole doxes me everywhere. So I have to do this re-edit of my own video because of this stupid scumbag being too immature to deal with facts, like what screen names are for. But anyway, yeah, so I'm just going to play my video in this video. So I'll even say, maybe I can throw in a few new insults. We'll see how it goes. So this should work. In front of draftphysics.com, debatephysics.com, also video presentation. So, we have these two physicists interacting at this moment, and they're completely ignoring every single argument I have actually made, so they won't counter any of my direct statements. Yeah, so they won't play even just a clip where I'm explaining it, except where they quote mine. So they won't just say, okay, his theory is that you can't make free momentum because extra momentum does extra work, and that's free energy. So yeah, you can't make extra momentum. That's not a real thing. And then counter it by explaining how free momentum isn't a problem. And so they keep doing all of this indirect nonsense, and much of it that, frankly, everybody who pays any attention to this channel, been around for a while, knows we've been over this stuff for 4 years. And the fact is there isn't any really good evidence. And somebody needs to make better evidence, not redundantly bad evidence. Right, so what we have is like the Mythbusters crash cars, but that's it. We don't have any car crash tests. We don't have ballistic pendulum tests. We don't have Joule tank tests. Something as simple as just dropping things into a Joule tank from a distance and just seeing how much heat they create. None of these tests have been done. That's the fact. None of this science has been tested. They just preach it as a religion. We're supposed to accept the existence of the holy scalar ghost without ever seeing the holy scalar ghost do anything, ever. 25 times the scalar ghost energy, to move something 5 times as fast. Show me. So anyway, that's the crux of the issue. So anyway, this Valerie Rousseau character is going to lie here, in the beginning of this video. I can't show his whole video because he insists on doxing me. Now, I think everybody listening, the majority of people on the internet kind of understand that people who resort to doxing other people, it's because they don't have an argument they can make. So they have to try to attack the person in some kind of way. And I've explained I don't live in my own house. Doxing me doesn't do any, I don't publish under my name, so it's not going to get you any search results that are going to be relevant to anything in the physics. And it's just a way of attempting to attack my personal life and to attack my security. Because, yes, I am a dissenter. Dissenters have a huge disadvantage. The minority opinion, has always been subject to this kind of violence from the majority. And so it just demonstrates he doesn't have an argument, because there's no reason to do it. There's just no good reason to use my name. I have a screen name. That's the name you should use. I don't publish physics under my name. It's just a fact, and there's just no reason for him to use this tactic. It's just disgusting, frankly. But anyway, and then on top of that, he makes this buffoon page where he writes a bunch of lies and fake narrative. So he can't deal with my real arguments. He has to just make up lies. And on top of that, he takes a piece of my artwork. Okay, maybe it's not his taste. I didn't do it for him. And then he defaces it. Defaces the penis. So, who does that? Really, it's just such a, what, you can't beat me, so you have to try to erase me? Is that it? It's just such a cowardly, unmale thing to do. So that's how this started, and I made it clear to him, okay, if you're going to fuck with me in this way, I'll fuck with you, fucker, because you don't give me any fucking choice. So again, he completely started it, I only reacted to it. So I said, all right, if you're going to force me to make a page about you, I'll do it. You're going to force me to Photoshop, I'll do it. Yeah, and it's not by my choice. I don't bother with this nonsense, these buffoon things, all this crap. I quote what somebody emailed. I quote what the fuck our conversation was. There's no use for any of this other crap that they force into the subject by keep implying somebody's an idiot or an asshole or put their little bullshit on top and all that crap. They're the one inviting those kind of arguments, not me. I'm not asking for that. I'm not asking for a Photoshop war. This asshole is. And now he's whining about it when he started every fucking bit of it. And he's just going to sit here and lie and pretend he's a victim of something. This fucking liar. I just can't believe people would defend such a cowardly liar. So anyway, let's play it.
Also known as draft science on YouTube.
It's not also known. That's what I'm known as. All right, and you're trying to change that. You're trying to change it. Not by my choice. You're choosing. You chose to use your real name when you wrote papers and did this and did that. That's your business. All right? It's not something I would do as a minority, okay? Somebody with a minority opinion, because it's just too fucking dangerous. Because you people, you majority people, you group thinkers are dangerous. And I have proof of that danger. I have been swatted twice. I've had all kinds of, spam and all kinds of, people create fake accounts, do all kinds of things, so it looks like I did it kind of crap. So this is a real threat, fucker, and you're playing with it. Demonstrating you have no character and no integrity. You're not a man.
Doesn't hesitate to display obscene and...
so whatever that is, whatever obscene is. So obscene is... Any human nudity is obscene. All right, so, I mean, that's hilarious, and it's on its face. But he works at a Catholic university, so let's understand. He's taken a loyalty oath, to the Holy Ghost. He believes in virgin births. That's his, he's willing to lie, and we know it's probably a lie, right? He doesn't believe that shit, to get a job.
Sexually explicit photo.
So it's not sexual in any way. Frankly, there's no sexually explicit part. Nudity isn't sexually explicit. I'm sorry, you really don't understand these concepts at all, do you? It is kind of funny. I just noticed. I didn't pay any attention before, but he's got this art on the wall, probably done by his fucking plumpy wife. And it's garbage. And he was attacking mine, which is just hilarious. Because by comparison, I'm fucking, brilliant. Fuck you. He's just such an asshole. Fucking asshole. What button do I hit? This one over here. Okay. There's no sex act in the picture, retard.
Photoshopped images of the physicists he attacks.
So whatever. I don't do it to the other physicists. It was just for you, asshole, as fair retribution for your insipid and silly lies and distortions and defacements. You're a petty, sick fucker.
Including some aimed at...
And now it's all public record. It's all public record what a sicko fucker you are. Okay, in the sense that how dare you imply that you have been victimized when you did it first?
Me. Anyway.
I mean, he put a picture, I paint nudes, right? Yeah, so he put a picture, a self-portrait I had painted, on his website. Why would he do that? It's a physics argument. He puts my self-portrait on his website, and then he defaces it. How is somebody supposed to react to that? Except with, oh, fuck you. How dare you? And his wife has something to do with art. She has some sort of art degree. I wonder if she thinks that's just a great idea. Let's all just steal people's art and deface it. That'll show your character. What a fucking lying weasel you are.
One who's seen his video.
I just hope your kids someday see these videos and can see what an asshole raise them. What a petty, sick fuck. And a stupid fuck to boot. Profoundly stupid. Can't even find the fucking arguments in the video.
Knows exactly what I'm referring to.
Right, go to his website. Well, you can't find it, frankly, and it's got 74 ads on it, so I don't even know why you'd bother. But he's got a whole profile page with all kinds of just absolute crap. There's no physics anywhere. There's just a bunch of slander. Alright. Yeah, now I have to edit the video. Yeah. You can't, it's just ridiculous to have to put up with this shit. That some fucking moron can't figure out that, reasonable ethics on the internet are you don't dox people for no reason.
Experience total destruction.
Yeah, dream on.
I already gave him a challenge a few days ago about Newton.
Right, and so I sat there and wasted my time, right, and he's implying it's a 2-hour video. No, the part where I answered his question is like 10 minutes. So again, it's not, no, it's not that arduous. I mean, do I actually have to play the video where I explain what I think, how it works? And then there's no counter explanation anywhere, right? So he doesn't provide his answer. So how's his answer going to be different than my answer? Did he show us that? No. I mean, this is just so insane. This fucker is just fucking insane. Oh, we have to move this properly.
Cradle, which he miserably failed.
So it's just some vague notion that there was some kind of miserable failure. So I don't know. Is there? So what was the miserable failure? I'm just curious. I said it was the speed of sound through the metal. And that the motion in the one object, because they're all the same mass, the motion slides right through them all. And because the last mass is free to leave, it leaves. There's not going to be a reflection because it's the same mass moving the same velocity, so the currency is the same, so it can fly right off. What's wrong with that explanation? There's no explanation for how it was wrong in any way. This is just such pathetic nonsense. He declares victory when he has done no work. He has said nothing. He has defended nothing. He has produced nothing.
He didn't even understand what the challenge was about.
Who did? What was the challenge? The Newton's cradle in the normal configuration with the same masses conserves both kinetic energy and momentum. So exactly what was the challenge? To explain the nuclear forces. Is that what you wanted? An explanation of the nuclear forces? Not in controversy in any way.
And made a fool of himself as he usually...
No, it didn't happen. Fuckhead. God, it's just amazing. So people ask, well, you think all the physicists are loony, crazy, motherfucking suspags? Apparently. Yeah, lying dumb fuckers. That was the problem. Physicists are lying dumb fuckers. It's so far, every single one we've gotten to interact has done this lying dumb fuckery. Every single one of them runs away after they've done a bunch of lying dumb fuckery. Every fucking one.
Does. So, to destroy him even more...
brother. So he provided no explanation. So there was no explanation for how I said a single thing wrong in my video. No quote, no statement, no nothing. Nothing to indicate I said anything incorrect. I mean, what a weasel.
I'm going to give him a simpler challenge which he will fail as well.
All right, so this challenge, again, is 4 years old. I mean, we've been arguing this stupid experiment where you crash a 1 into a 2 and end up making free momentum. And so I'll play Professor Lewin doing it, and I'll show the obvious, okay, that, shenanigans.
I have here an air track that is equipped with a motion detector at both ends.
Detector.
Then I can place on it a glider that...
So it's a cheap air track. So let's just point that out. This is the $500 version. Lewin has the $10,000 version.
that undergoes a nearly zero net force.
Right, and watch this.
Doesn't understand what a network.
Yeah, right. So we have no idea how level this is. So you know, we always know that these carts start accelerating. It's a little dicey getting it perfectly level.
Is. So let us simply tell him that the result is that the glider moves at constant
whatever, says you, but okay, fine.
velocity as long as it doesn't collide with anything. And there is a computer that collects
Yes, so fine. The computer's going to collect your data, fine.
the data from the motion detector.
But you can't take an average velocity. You can't do any of that crap. The only velocity that matters is the velocity it's moving when it hits the other cart. That's the only velocity that's relevant.
In particular, the velocity as a function of time.
So there's no reason why he can't just let these carts hit each other. Hard aluminum is pretty elastic, and he could even put a little piece of steel on the cart and have two pieces of steel hit each other. Be very elastic, so you don't need rubber bands and springs. Elastic is metal against metal. That's elastic. What he's doing is super elastic, so it should just be understood that the rubber band isn't going to help the experiment, because the rubber band is going to do what the spring does, which is not give all of its energy back.
Now let us measure the glider's mass. 201.4.
So this is doing the experiment the worst way you could possibly do it, because he's not going to have 2 to 1 or 1 to 2 and 1 to 3 or 1 to 4. No, instead it's going to be 1 to 1.5. Something about there.
5 grams. This is the mass of our first glider. Then I have a second one here to which I've added some extra masses.
I mean, it's funny that these are the suckers who buy this crap from that companies, these companies that manufacture this shit just to sell it to dopey school teachers, because they don't know any better. So they pay an exorbitant amount of money for a very cheap version of the device. I mean, you can see this is just such chintzy carts.
301.6 grams.
Right, so it makes it pretty much a 1 to 1.5.
0.5. No, 0.6. Now, these two gliders, they can collide elastically, which means that the total kinetic energy is conserved. Of course,
the total kinetic energy won't be conserved, but whatever. Play along.
Of course, Gary doesn't understand what kinetic energy is.
Yeah, that's right. I don't know what a scalar energy is. I've never seen a drawing of it, never saw a picture of it, never saw a goddamn thing to indicate there's any such thing as an energy with no vector. It's a silly concept. It's absolute nonsense. The universe doesn't have motion with no vector. Doesn't do that. Moron. So look how he films it. 45-degree angle, and we can't see a goddamn thing. Yeah, great. Oh, just amazing.
Alright, so I'm placing the second glider, the heavy one, at rest, and I'm going to give the first glider some initial velocity.
So we have no evidence whether this glider, if you let go of it, wouldn't start accelerating. So he didn't do any test for that, whether this end is actually level. But whatever.
So that they will collide. And for the first part of this video, I am hiding what happened.
Okay, so there's really no point. So the first part of this video, I'm hiding this. We all know the experiment. We've seen it all hundreds of times. I mean, what the fuck? You're such an asshole and an idiot. We've all seen maybe literally 100 versions of this experiment. And he's going to show up and say, oh, I'm doing something new and innovative. No, you're doing it exactly the way everybody else does it. Shitty. So you can't see a damn thing. I can't test anything with frame rates. Can't do a damn thing with your video. It's absolutely useless to be in some way critiqued. All right, so I guess we'll just play it and see what he says. So he's not going to give us any data. All right, because he thinks I don't know what the predicted outcome is. And of course, I've done videos where I've listed the whole thing going all the way down. So let's understand. They actually think when you throw a tennis ball at a brick wall and you get most of your energy back, that you really put twice the energy into the wall. And then if the wall moves, okay, and you don't get much back, that somehow it didn't absorb the energy, when of course it did. That's why you didn't get anything back. Yeah, it's because it absorbed the energy. It's just too silly.
Happens after the collision because I am challenging Gary to predict it using his crackpot.
Right, the crackpot theory is that you can't make free momentum. That's my crackpot theory. All right, so I'll show the Professor Lewin experiment. All right, and you can see where, shenanigans. And then I'll show when he does it when he's not trying to do it. Okay, and the results are perfectly conserving of momentum.
Science. Of course, to make the prediction, we need to know the initial velocity.
Let's just make sure. We'll put him. Let's see, where will we put him? Let's see, where's a good place for it? We'll put him right over here. Yeah, I really don't like that. Let's see, maybe over here, like his little patch on my sleeve.
Of the first glider. So let's look at the data that the computer collected.
So he's not going to let us see any of the real data, so this is going to be useless, I imagine.
Again, I'm hiding the part of the data that shows what happens after the collision.
So, is this childish or what, right? This is just such a waste of time. You're going to make an argument, you say you have proof, well then show us the proof. Why are you playing these stupid games? Who does this? This is the 13-year-old would be above doing this. What's the point of it?
I will show the full thing after Gary will have responded, or after he will have cowardly fled.
Oh, whatever. It's just, I'm not going anywhere, fucker. I've been doing this for 10 years, asshole. I haven't run away from anybody's arguments, jackass. I never stop talking, fucker. And I'll keep talking about you, asshole, because you're a perfect demonstration. Every time somebody tells me, well, do you think all the scientists are assholes? I'll use you as the example.
So the upper graph represents the position of the two gliders, which is irrelevant for the prediction.
The position is irrelevant for the prediction, whatever that could be. Yeah, we don't need to know exactly where they are. We just want to know how fast they leave.
The lower graph shows the initial velocity of glider 1 in green and the initial velocity of glider 2 in purple.
Alright, well, if this green is the initial velocity, let's see if it's a sloped line at all. It looks like it slopes a little tiny bit, but it's very small. But we'll see.
The software can give us the values of these velocities with 4 significant figures, but I guess Gary has no clue what this means.
Yeah, whatever. I guess, I do this, I suppose. You just talk shit. Again, my videos some are 5 minutes long, some are just 10 minutes long, and all you have to do is show what I drew and then explain how it doesn't happen. Why can't you do that? Or explain how you could do the further experiment, which is, well, since you're making free momentum, you could do the same experiment again. You could have a third cart that weighs twice as much, and then you could increase your momentum by another 100%. So why don't you do that? Why don't you show us you making more and more free momentum? Because free momentum doesn't mean anything. It's not a problem. Experiment's working just fine if you're making free momentum. That's their argument.
Anyway, in order to obtain these values, I select the region before the collision happened where the velocities were constant.
I don't even know what that means, but that's a little scary, isn't it? Yeah, it's supposed to be always constant because it's an air track, so there shouldn't be any problem getting constant velocity.
The computer gives the statistics, and the value of the velocities are given by the mean values. Of course, the initial velocity of the second glider in purple was 0 meters per second since it was addressed. And the initial velocity of the first glider in green was 0.3590 meters per second.
And that's if I can trust your calibration of your device. So all he has to do is calibrate his device wrong, and it's going to give you fake and phony numbers. So again, film it with a nice high-speed camera, film it well, then let us test it ourselves. Let us test the actual video.
So the question is very simple, Gary. You know the masses of the two gliders and their velocity.
Right, so this is just a waste of time, but I guess I might as well just play the rest of it. Yeah, obviously we've done this over and over and over again.
Before the collision. I challenge you to predict their velocities after the collision.
Yes, I'll predict that you can't make free momentum.
Without using conservation of kinetic energy, since according to you, the concept of kinetic energy is pure nonsense.
Yes, kinetic energy is pure nonsense, and anti-momentum is pure nonsense. There's no such thing as anti-motion or unmotion. You can't undo a motion. You can counter it, but you can't undo it.
Now you are facing a trilemma.
Oh, brother.
You can make wrong predictions.
Whatever. No, I can judge your experimental process, okay, and that's what I'll do. But these outcomes are going to be very slim anyway. The less difference there is in the masses, the smaller the margin of difference. So these numbers get tighter and tighter, and fudgeabler and fudgeabler. So that's why it's best to do the 1 to 3 or 1 to 4 or 1 to 5. The bigger the difference, the bigger the difference. And it's just so much easier to see the difference with the higher ratios of mass. Mass.
In which case, the experimental values will prove you wrong when I will release the second part of this video.
Yeah, well, we'll see.
You can make a correct prediction, but the only way of doing so is to make use of...
I know there's no free momentum, so I know there's no such thing, okay? So you can't keep making more momentum. I've drawn it. I've drawn the pendulum experiment. One mass banged into say a 7 or 8 mass. It could hit 100 times. And each time it hits, it's going to push the 10 mass, or whatever mass you use, with, by your theory, twice the momentum. Now, none of that's going to happen. You're not going to be able to move something with 200% of the momentum this way and get 100% back that way. That doesn't happen anywhere. So if it moves, it's not coming back. That's the truth. Just like a tennis ball against cardboard. You're not going to get much back because the cardboard is going to move. Tennis ball against brick wall, yeah, you're going to get a lot back because the wall ain't going to move. Those are the facts, moron.
Conservation of kinetic energy. In that case, you will just have proven your own theory wrong.
I didn't do any such thing, but whatever. It's fine. Go ahead and make your assertion. You can add your silly experiment to the list of silly experiments, and we'll see where it fits as credible.
You can keep blatantly lying and claim that the experiment is wrong, but you are not going to fool anyone.
I'm going to do what's fair and rational, which is make fair and rational statements about what's obvious in these experiments. So I'm going to show the Professor Lewin experiment, and I'm going to point out it's got some obvious defects. And if that was an experiment that was proving me right, I'm sure you would see those defects. So that's the duplicity of you lying scum. If I did the experiment with those glaring defects, you'd sure jump up and say, hey, but there's huge defects in your experiment. I mean, you're just such scum.
Not even your stupid dedicated followers, since anyone can check by themselves by doing the experiment.
Why would they do the experiment when it's been done better, on better equipment? Yeah, okay. Yeah, it's just too ridiculous. I mean, I did build an air track of my own design. I thought it would be superior. It was basically a PVC pipe inside of a PVC pipe, you know, so So I thought it would get rid of gravity being a real issue, and but now it still wobbles way too much. So and it just has every capacity to tilt in a direction, which just means it creates an air exhaust, which is a jet engine. So we have no evidence that when these two carts he's talking about collide, that they don't do this. I mean, they can't really do this, right? So they really have to do this, up. And then when they go up, they're shooting air out. And so they create a little extra velocity. Perfectly reasonable argument. There's a new source of energy in the experiment. The air track itself is producing a lot of energy. And if that energy is allowed to leak into the experiment, yes, it can fudge the results. Just a fact.
So go ahead, do your usual insulting and obscene videos. You already lost the challenge before.
I didn't lose anything, and again, you're the one who was obscene in your behavior first. And I made it clear I had no interest in your mockery and buffoonery, and I would like to make physics arguments. And you're the one who is insisting, okay, that it be polluted with all of this time-wasting insults.
Or even starting, Gary. And people know it.
Well, we'll see what people know. I'm just saying, you think your statements are going to counter-argue my logic of saying that I haven't done anything wrong. I didn't ask for a shit argument. I asked for a physics argument. It's in every video I make. I'm asking for a physics argument. And the simple fact is you couldn't produce one. All you could do was mock. You create a whole web page that was just mockery. There was nothing there. It wasn't a physics argument of any kind. So fuck you. You're a petty weasel. A childish moron. That's it. Okay. So, leave us go to the Professor Lewin video. Alright, so I'll pause to do that. Alright, so we will go back, okay, to the other Professor Lewin video. But this is the classic, the video that started it all for me. Okay, so physics girl, whatever, 5 years ago, she made some silly video, and she basically said that yes, the 5-ton train collides into another 5-ton train, and not moving, and the combined object leaves with half the velocity, and so it's perfectly conserved the momentum, but it wiped out half the kinetic energy. And then she showed a bullet crashing into an egg or something, and then a tomato smashing, and claimed that the half the energy is in deformation and heat. Now, there'll be no evidence that there's any such thing in this experiment. So Lewin's going to be doing that experiment. Now, look, it is just a fact that it's even better if you drop the weight on top of it, because then you're using gravity to combine the objects, so you don't have to use part of the momentum to do the connecting of the objects. But regardless, he's going to get close to 99% of the momentum conserved here. All right, and then they're going to claim there's a bunch of heat somewhere, and there's a bunch of dents and deformations and all kinds of things happen. Now again, the dents and the deformations can't matter. So if you know anything about physics, you know if I dent something, that's not the end of the energy, right? So if I deformed it, that doesn't mean the energy's gone because it's deformed. The deformation doesn't mean the energy's gone. The deformation is just a process through which the energy transitions into heat and other things. So the energy's still going somewhere. It's still somewhere in the environment. It doesn't get used up by deforming. The energy's not gone. It's not used up. It's still moving. And these morons can't even understand that argument. And Descartes got that right 400 years ago. Yeah, it's just, these people really are just such weasels. Ugh. Disgusting. All right, so this is a one mass against a one mass. They're going to stick together, become a two mass going half the velocity.
Ready?
All right, and what do we got? We got almost, right? So we lost Let's see, 8 plus 2 2 is 4, so you lost 12. So that's a, you know, it's not an insignificant amount of, you know, it's 12 out of 200, or you could say 12 out of, you know, it's not 10%, it's like 5%. So it is a significant amount of momentum lost. But the fact is you conserved all the momentum, and frankly the kinetic energy is gone. I mean, half the kinetic energy has just disappeared. And they're going to claim that it's that Velcro got really hot. Do you believe that? I mean, you're really going to fall for that crap?
All right. What do we see? 1 3 8 2 8 8. 1 3 8 2 8 8. 1 3 8 2 8 8. Divide this by 2 is 0.144. That is, the difference is only 6.
6, yeah, so it's like 5%, 4%.
And that is only 4% off.
There you go. So you lost 4% of the momentum. So like with the ballistic pendulum, you can argue that, yes, there's some heat in the ballistic pendulum. You lost some of the momentum. It has to be somewhere, right? Where is it? Well, it's got to be in the form of some other little shit moving somewhere that you can't see. So it's got to be being radiated out as heat in some other kind of movement. Some other kind of... And again, movement doesn't even count. Like I said, even if you bent the little fibers of the Velcro, the only way the energy leaves is from the heat that's dissipated from the bending. The bending itself doesn't use the energy. Nothing uses energy. I guess that's a simple argument to make. You can never use it. You can only have it for a while and then lose it. You can have it and lose it. You can't use it. You can't use it up. You can only be a vehicle for its transformation. You can only make it go from being a big object into a little object. But you can't undo the energy. You can't anti it.
That's completely within my prediction that each time could be off by 2.5%. Now I will have a car which is twice.
So he just says 4% off, and he says it's right inside it could be off by 2.5%. 2.5% is half of, it's almost half of 4. So you're twice your prediction. You're outside your prediction by twice as much. So even I didn't realize he said something that kind of silly. So you're predicting more conservation than you actually got. So maybe you should have done it a second time. Well, anyway, this is the experiment that counts. So
the mass?
Well, the other one counts. I mean, it's just so obvious that this silly notion that I can connect two masses and somehow lose half the kinetic energy is just so ridiculous. That there's no physics, no technology. I can't put a quantum Velcro. I can't make entangled figure faggers. I can't do anything to make it any better than losing half the energy. I can never do better. All the king's horses and all the king's men and all this dummy, dopey scientists can't come up with a way to make the kinetic energy not get wasted. Isn't that funny? And this is the stuff they say that does work. So obviously it doesn't do any more work than the momentum did in this case. Obviously. Well, I mean, you people, I just can't believe I have to do this year after year. You're so dishonest. You're so fucking stupid and creepy, and you're just such scum.
And this is once the mass.
Once the mass. All right. So these carts are so much cleaner than the other carts he uses earlier in the same lectures. Let's understand, this is the same lecture. Everything I'm going to show is in one single lecture.
I will set them again to 0.
All right, look how pretty that is. Ooh, pretty, pretty. Yeah.
0. And now we get 1 onto double the mass. We ready?
So yeah, we can't see the other cart, but I'll try to catch that.
There we go.
There we go. Ooh, nice and clean cart. Ooh, clean. All right. So obviously a 1 mass against a 2 mass, and the little strips of Velcro. So again, when you're doing the other experiment, why can't they just use let the metal hit the metal? That would be elastic. Why do they need some contraption to stick to these things? It just makes the point. So don't be fooled. These detectors aren't attached, so it's just a card that's going through the light sensor. So there's a card on the other side. Now, you could argue that, well, if you look at these 2 carts, there's not 2 Velcros on here. There's only 2 on here. So, yeah, maybe it's a little less than, twice the mass. But whatever. It's a reasonable argument. The carts themselves, the naked pieces of aluminum, are in a ratio of 1 to 2. So this really shouldn't be an issue. But anyway, let's do this. Oh, they bounced. Okay, and what's the result you get? Okay, so the results demonstrate, first, the 1 cart, when it bounces, doesn't go backwards. It's still going forward. All right. And it has a real velocity forward. And obviously the 275 number is, what it should be in terms of the momentum of the twice as massive cart. And so, you need the initial velocity. Oh, yeah, I got to wait for the other number. Sorry. That's the initial velocity, 275.
You see, they bounced. They didn't
slide
stick.
Over. Oh, come on, please.
So we have to start all over. If they don't stick, of course, then it's...
Oh, that's right. He's only using these 2 timers. So there's no initial velocity? Oh, there must be, because I did this before. All right, I'll take a pause and see if I can figure out what went wrong. All right, simple mistake. Obviously, it's these counters are counting the amount of time. So the higher the number, the more time, which means the slower it's going. So this 111 is the initial velocity in. It didn't detect the continuing velocity, just the initial velocity. And this number is the velocity coming out. And as you can see, it's well over twice, which means it's going less than half the speed. So it's going less than half the speed of the cart that went in. Much less. 75, well, let's say 64, okay, worth slower. So it's less than half. Not more than half, less than half. It's supposed to be 133% of the velocity. It's supposed to be 3/4 of the velocity. It's obviously not 3/4 of the velocity. It's obviously less than half the velocity. So that's what happens when they don't rig the experiment. Yeah, that's what happens. All right, so let's go to the other one. All right, so this is the other version of the experiment where he's doing it on purpose. So this is the initial velocity. This is the velocity that the heavy cart goes, and this is the velocity of the return. Okay, just wanted to use my pointer. Okay.
So you're going to see this one come in, give you the time here. This one go through here, gives you the time here. This one will come back, gives you the time here. Are they 0?
All right, so there you should be able to see the carts fairly well. I guess I'll blow that up just to emphasize the point. All right, so the 1 mass cart has this blob of clay on it. Now, there's probably a blob on the other side to balance the cart. And obviously, if this cart's going to be twice as heavy, it has to have 4 blobs of clay on it. And it doesn't have any blobs of clay. And obviously, if this has 2 bumpers, then this has to have 4 bumpers to be twice the mass. And if this has 1 little hunk of weight, this one has to have 4 little hunks of weight. Twice as much weight. There's no evidence that it has twice as much weight. So it's pretty implausible just looking at the carts. I don't think it's even reasonable for somebody to say, "Oh, yeah, that's the very good configuration. She certainly is twice the mass," because it doesn't, frankly, add up to be twice the mass. Just by, like I said, if I did the experiment and it looked like this, it'd be really easy for you people to say, "There, he fixed the experiment. He rigged it." So, if you don't mind being hypocrites, then go ahead and say, blah blah blah. Now, another funny thing is he takes the tape measure and they turned it upside down, and it's just like, why would you turn the tape measure upside down? But whatever. But incidental to the whole story. Okay, so let's play the videotape and such.
Okay, you ready?
So he does have to, even on the $5,000 or $10,000 air track, he still has to hold the cart, or it's going to end up moving on its own. And so he's put in his initial velocity. Now he has to let go of the other cart before it hits. Maybe he did. Yeah, maybe. All right, so we have the initial velocity is 123. This one appears to be the motion of this. I guess this cart hasn't moved yet. Oh, yeah, it hasn't got to the timer yet. So he has this timing gate pretty far away, which is a little strange. All right, so this is the return velocity. And now that one's going through the gate, so its time should show up. Okay, 186. So obviously 186 at 123, you're talking 186 is really fast, okay, because that's faster than half the speed. So it's twice the mass, and they're claiming it's going much more than twice the speed. Twice the speed half the speed would be 246. Huh? Wait a minute. Yeah, 246, and it's only going 186. So obviously, much faster than half the speed. And so right there I say, bullshit. Free momentum is not a thing. You can't do that. And the other experiment was clear. You only had a certain amount of momentum to use. If it would have made more momentum, you would have said, no, how can it? There's only 2 carts, and how can it make more momentum? It can't happen. And this experiment's making more momentum. And it just doesn't mean anything to say, well, there's a momentum going that way. Well, the momentum going that way can't undo the motion going this way. It can't undo it. How much time somebody have to say that? So anyway, I'd say yes, garbage experiment. That's my conclusion. This is rigged. The mass isn't twice as heavy. That's why it gains so much more momentum, is because it's clearly not twice as heavy. All right. So, so that's probably enough. And so I guess I could just draw the solution to his moronic speculations. I don't know if there's a point in using Lewin's equation. I guess I could. Let's see if it's on the blackboard here. No, that's not it. Oh, well, this is let's play that part where he's talking about the free momentum, the 200% of your momentum ends up inside the brick wall. Yeah, that's pretty funny. So I might as well enjoy that. Okay, so he introduces this by saying, well, I'll give you some sleepless nights. Well, stupid, idiotic nights.
Now, I want you to have a sleepless night. I want you to think about the following. And if you can't solve it before the night is over, then I really think you should lie awake.
So why would physicists play this kind of a game, right? So he doesn't want to tell the solution. He doesn't want to explain what he says happens. Now, I think what he says happens, he has 2 different answers. He has one answer that doesn't have any answer at all, where the motion went, and the other one says the whole Earth moved.
Here is the wall. Here is a tennis ball that comes in with a certain mass m.
All right, so let's just redraw the experiment. Just change it a little tiny bit. And so, let me use my pointer. So instead of this one mass, this mass ball, let's make it a pendulum. And so now we're just going to pull it back, and then we're going to let it hit the wall. And then it's going to reflect. And then it's going to hit the wall again. And it's going to reflect. And it's going to hit the wall again. And he's saying it's going to get 100% going back this way. And 200% going in. So you can sort of understand that the wall is going to collect an awful lot of momentum. Too silly. It's just silly shit. It's nonsense. It don't happen.
And it has a certain velocity v, whatever that is. It's a nearly elastic collision, and it bounces back from the wall. And we all know that if it's a nearly elastic collision, that it comes back with the same velocity.
There you go. Well, it can't be nearly elastic and the same velocity. It has to be perfectly elastic to get the same velocity. But it's physics. Who needs to... We can fudge all the details we want. None of that shit matters. But anyway, the point would be is that, yes, if you got all of it back, you could do this perpetual motion thing. Because instead of this wall, I can just change this to a 10 mass ball and a 10 mass ball and a 10 mass ball, and I can have them on a conveyor belt. And so each time the thing bounces all the way back and can hit another ball, hit another ball, hit another ball, hit another ball. That's their theory. I can get 200 momentums going this way. See, they say if it's 1 to 3, I can increase the momentum by 150. But if I make it a 1 to 10, then I can get almost 200 going this way. For a total of 300 with each impact. So that's how ridiculously, paradoxically insane what they're arguing for is. Again, how many times do I have to say it? 25 times the fuel to spin something 5 times as fast. It doesn't happen anywhere in this fucking universe. Why the hell are you defending this rubbish? It's so depressing that people are this stupid. I mean, I know, really. Earth needs a yellow bus to come, It's retarded. There's no point in 100 billion neurons and you people can't do anything better than this crap.
Kinetic energy is conserved. All the kinetic energy is in the tennis ball. Nothing is in the wall. The wall has an infinitely large mass.
So no kinetic energy is in the wall. But somehow the momentum is. So there's mv, but there's no mv squared. How could that make sense?
But the momentum of this tennis ball has changed by an amount 2mv. That momentum must be in the wall. It's non-negotiable.
Yes, it is negotiable. Yes, it's completely rejectable as an idea. Reflections are a thing in the universe. You can have reflections. And reflections don't mean you used any energy. So you can make U-turns. You can do things that don't require you, to do to create the turning force. And the fact is the wall has a huge buffer. And what it'll basically do is when you push in one place, it will use its buffer to push it back out. Because it has a huge buffer.
Because momentum must be conserved. So now here you see in front of your eyes a case that the wall has momentum, but it has no kinetic energy. Can you understand that? Can you reconcile?
No, you can't reconcile it. You can't do anything with it. What form is the energy in? So if you say the Earth moved, well then you do have kinetic energy. But the velocity is so small that it's only a tiny, tiny bit of kinetic energy. But you still have it. So you can't say it moves and it doesn't move. Either it moves, then it used the energy. If it doesn't move, then it didn't use the energy. But you can't use the energy twice. You can't plow into two things and make them leave and have more total momentum than you started with. You can't do that. The vectors in this direction don't cancel. They all have to come out of whatever you started with. You have an arrow, a magnitude. The other two balls can't have arrows that are longer than that magnitude. Fact. You can't conserve. kinetic energy. You can only conserve the momentum, and direction can't matter. All right, that's probably enough. Right, I think that's enough. Oh yeah, I was going to look for his equation. I'll be close enough, my guess. I'll be 1 or 2 numbers off, but I mean, it's a pretty simple idea. If it's 33% when it's 1 to 2, and it's 50% when it's 1 to 3, then you can sort of understand the pattern, okay, that it's going to be like 17, for the 1 to 1.5. So it's going to be something like 15 to 17 will be the number. But it ain't going to happen in reality. Chicanery might make it happen, but reality won't make it happen. So yeah, maybe I'll draw that. Yeah, I think I can do that while I'm here. So I was arguing this earlier, and that's why that's still there. But anyway, this is the simple brick wall argument too with the spring, and it's just it's an absolute fact. I have put the same compressed spring. I put it between 2 one-mass objects. I'm going to get a velocity. I put the spring between a brick wall and a one-mass object. I'm not going to have 200 momentums in the wall and 100 here. That's not going to happen. And what I am going to get is twice the velocity. This object will go with twice the velocity because the only way the spring can expand is in the direction of the one mass. It's not expanding in both directions. So obviously these go 50%. Okay, 50% of this 100% speed. And not to be able to understand this stuff or argue, it's ridiculous to have to argue this crap. All right, so in the example provided, stupid air cart thingy, slightly heavier mass, 1.5. Okay, awkward kind of numbers. And again, the simple truth is, so yes, this velocity, all right, going this way will be 15. Let's see, so 15 would be, what would be the total velocity? It's 15%. So it's going to have 15% more momentum from that calculation. So the mass, the velocity, so you know what 15% is going to be. And likewise, this one is going to be speculated to go this way with 15%. Okay. And that's their argument. And, well, it's not 15, it's 115%, sorry. 115% of the momentum. So the MV number for this one will be that. Now, I'm arguing that if you do the experiment right, that ain't going to happen because this is 1.5 heavier. Okay, so it can't be going faster. Let's see, so it's 75% for the 75%, and then it's only 50 velocity. So it's half the velocity, then 3/4 of the velocity. So, it'd be something like 5/8. It'd be higher than that. Yeah, I guess I probably should just do their math. But let's just say that's not what I'm arguing. I'm just saying you have to conserve the momentum. So in my opinion, the total of this and this can't exceed 100% of what you started with. So the energy in has to equal the total energy out. That's the simple argument. This MV plus this MV, okay, will equal MV in. Now, that's the simple argument. All right. But again, he has a rubber band in there, so we know we're going to lose a little just from that. So we'll have to see if he makes so much free energy that even the losses to the rubber band don't show up. Because he's making extra energy somehow. And again, the simplest explanation is there's just no evidence that these carts, when they hit each other, that they don't lift up a little bit. And all I have to do is lift up a, 1/10 of a millimeter. They raise up a 1/10 of a millimeter. that's a place for all this extra air to go out. It's like increasing, the hose or doing something else. You're making more volume of thrust. You're increasing the thrust. Alright, so enough of a video, I think. And so till the next time, and such, and so forth, and whatnot.